Hi, class. How are you today? That's great. I will now transform back into Mr. Babbitt.
The learning target for today is to transform shapes using translation. The scale for today is a 3. You can translate shapes and find the translation rule if given a translation. So one is that you can translate shapes, and the other is that if you're given the translation, what's the rule? A 2 will be you can translate shapes or you can find the rule, but not both. A 1 is you can translate shapes visually, like you can physically move them, or mathematically, you can move them using the math rule, but you can't do both ways. And 0, you cannot transform shapes. Let's get started. So this unit is called Transformations. And in this unit, we're going to learn about 3 types of transformations: translations, reflections, and rotations. For translations, it's all about moving the shape, just taking a shape and moving it from one place to another, not changing anything else about it. For reflections, you're taking a shape and mirroring it over a line. And rotations is taking a shape and turning it or rotating it around a point. And all 3 of these transformations are called rigid motions. These are called rigid motions because they do not change the size or shape of the figure. So they might move it, they might change the orientation, turn it around, flip it, but the figure will stay the same. It won't change size, it won't change shape. And at the end of this unit, we're going to combine all 3 and do what's called composite transformations, which are just a combination of translations, reflections, and rotations. To start off, we're going to look at some vocabulary about translations and transformations in general. The first word is preimage. This is the original figure prior to a transformation. So it's whatever you start off with before you do any transformations at all. The next word is image. This is what the figure looks like after the transformation. So after you do whatever transformation you do, this will be your final object. This will be what your object looks like. Translation vector is a ray that defines the magnitude by its length and direction of the transformation. So this will be the thing that tells us where to move the object to.
And the last term is rigid motion, any transformation that preserves congruence. So translations, reflections, rotations, all the ones we're going to learn about are rigid motions. There are transformations that are not rigid motions, but those 3 are. They specifically preserve congruence. So that means their size and shape do not change. Their size and shape stay exactly the same the whole time. The only thing that changes is their orientation. You can flip them, you can turn them around, you can move them wherever you want, but they stay the same size and the same shape.
Next, there are a couple properties of translations. The first being that the preimage and the image are always congruent. So that means the object that you start with and the object that you end with are exactly the same except for their position. They're just moved, but they're the exact same object. And the second property is that line segments linking a vertex of the preimage and the same vertex of the image are congruent and parallel to each other. That means the translation vector at each vertex is congruent and parallel to every other translation vector from every other vertex. We'll talk more about those once we start drawing them. Now for some actual examples. Let's look at this graph here. We have two shapes. We have a brown triangle and a blue triangle. The brown triangle is what we'll call our pre-image. That's the one that has not been transformed yet. So we'll call that triangle ABC, and it is translated to become the blue triangle, so it's just moved. To show that it's been moved, we'll show our translation vectors. Notice that the translation vectors all have the same slope and length, as I mentioned before in the translation properties. So the translation vectors, they all go over 5 and down 1. So from each vertex, they bring a corresponding vertex and create the image triangle. Since this new triangle is the image, its vertices will be known as A prime, B prime, and C prime, with little apostrophes being noted as prime. So you can tell which one is the pre-image and which one is the image, because the image will always have the prime marks. For this example, we're going to transform triangle ABC using the transformation rule that they give us. And in this case, they say xy transforms to x minus 6, y plus 2. What that means is, for every point on that shape, we will move horizontally to the left 6 units, because it's negative 6, so we'll move to the negative side. So we'll move left 6 units and up 2 units because it's plus 2. So remember, x is horizontal movement, y is vertical movement. So if you look at point A, that is currently at the point 8, 8. Point B is currently at the point 10, 6, and C is currently at the point 2, 2. So we'll throw these down here so we can see A is the point 8, 8. B is the point 10, 6. And C is the point 2, 2. So now what we want to find is our A prime, our B prime, and our C prime, the images. So to do that, we look back up at the transformation rule and we see x minus 6 and y plus 2. So for point A, we have 8 minus 6 is 2, and 8 plus 2 is 10. For B prime, 10 minus 6 is 4, and 6 plus 2 is 8. And for C prime, 2 minus 6 is negative 4, and 2 plus 2 is 4. So now we plot those on our graph to make our image. So we plot those 3 points and then draw our triangle. And now we have our translated triangle. See, it looks exactly the same, but it's just moved. And finally, we'll label our point A prime, B prime, and C prime. So for the next example, they want you to look at the translation that's happening. They show you a triangle ABC, and then a triangle A prime, B prime, and C prime, and they want you to figure out what is the rule. So remember, the rule is shown xy, and then with an arrow, and you have to say what the rule is. So to start this, let's write down what points we have. So we have A is the point 2, 1, B
is the point -6, 4, and C is the point -3, -2. And then our translated triangle, our image, is A prime, which is the point 6, -2, B prime, which is -2, 1, and C prime, which is 1, -5. So if you look at the x coordinates on each of these, for A, we have 2 to 6. Well, to get from 2 to 6, you have to add 4. Let's make sure it works on the other ones too. -6 plus 4 is -2. -3 plus 4 is 1. So that means we add 4 to the x. So x becomes x plus 4. And then for the y, let's look at the y's. We have 1 to -2. To get that, you have to subtract 3. 4 minus 3 is 1. -2 minus 3 is -5. So for the y's, we will subtract 3. And there we go. There's our rule. X becomes x plus 4, and y becomes y minus 3. In this final example, we have triangle A prime, B prime, C prime is the image from translation rule xy into x plus 7, y minus 4, and it wants you to find the pre-image. What that means is what we are given now is the image. We're given it after it's been translated, and it wants us to find the original image, the pre-image. What did it look like beforehand, before the transformation? So we see that A prime is the point 2, -2. B prime is the point 2, -4. And C prime is the point 5, -3. So using that and the translation rule, we want to find what the original pre-image was. So we want to find what was A, what was B, and what was C. So the translation was to add 7 from the pre-image, the x coordinate, to get the image. So if we look here, A prime, its x coordinate was 2. So if we do the opposite and subtract 7, we'll find out what 7 was added to get to. So 2 minus 7 will give us -5. And then we see here that A prime was -2 for the y coordinate, and we had a y minus 4, so that means we do the opposite and add 4. So that'll give us 2. And we do the same thing. We're just doing the opposite of what happened. So B prime was 2, so subtract 7 to get -5. And B prime y coordinate was -4, add 4 to get 0. And for C prime was 5, so subtract 7 to get -2. And the y coordinate was -3, add 4 to get 1. And we have our coordinates, and all you would have to do after here is just plot the points and make your final triangle. Alright, now for the sponge activity. In number 1, I give you these points, and I want you to graph the shape. Then, I want you to graph its image if it was translated 5 units up and 2 units to the right. So you're going to be graphing 2 images, the pre-image and the image.
And then for number 2, I give you an image, a pre-image and an image, and I want you to write the translation rule in the form I just taught you. For number 1, you may use draft paper, or you can just make your own draft, whichever is easiest. Just make sure I'm able to understand it, and make sure to mark your axes and such as 1, 2, 3, and X and Y and that sort of thing. Alright, once again, please make sure to take notes in the entire video and circle 0, 1, 2, or 3 where you think you are on the scale. Take a picture of your notes, submit them to
Google Classroom.
Have a good night.